right. Welcome back to the Ethereum Protocol Fellowship Study Group. We are on week 8 now, and this is the development track session for week 8. We are here talking with Paul Harris from Teku, who will give us a deep dive into the Ethereum consensus client architecture. I'll pass it off to Mario. Maybe give us a little bit more in-depth intro for Paul here, and then we'll kick it off.
Hey everyone. First of all, Paul, thank you so much for joining us today. One thing you should know about Paul is that he's in Australia. It's very early for him today, so really thank you so much for making it and joining us today here, because we're very eager to learn about the consensus layer and about the actual client architectures. In previous weeks, we had an insight into the consensus layer, more abstract from Alex Stokes. We saw the execution layer client, and today we'll finally also dive into the real code base of consensus client. And specifically, Paul prepared for us a little presentation about how the EIP or an idea becomes a specification and then gets implemented. What is this process that we've been discussing in the study group before? So we are very excited to learn about that. Paul is working on the consensus client Teku as part of consensus company, and it's been a while. I believe Paul has been around Ethereum for a few years already. He's been also doing AMA for the protocol fellowship last year, a year ago, but it was like non-technical. We had really nice chat there, but it wasn't really the technical deep dive. So yeah, excited to have that with you, Paul. The stage is yours. Feel free to share your screen and get us through it. Thank you so much again for being here.
Awesome. Thanks very much for inviting me. My sound's okay, I assume. I'm just using headphones, and they do tend to be interesting sometimes on Zoom, so I thought I'd check.
Sounds great.
Awesome. So I'll share a screen. Sorry about the background. Usually I hide the cupboard and everything. Present my screen. I've prepared a bit of a slide deck just to make it a bit more like not just me talking. As it's already been said, I work on the consensus layer on a client called Teku, and I do have to say that the views expressed are mine, and they do not necessarily reflect the views of consensus. Just a quick little bit about me. I'm a blockchain protocol engineer with Consensus, the company Consensus, and I work on consensus layer client Teku. I'm also a maintainer on a couple of REST APIs, which is the Beacon API and Key Manager API, and they're the main APIs that the consensus layer uses to do different things. My team's got 7 software engineers in it, and 4 in Teku, and 4 in Europe, and 3 are in the APAC region. But we operate as one team. I figured I'd start off with going through at a high level about the consensus layer. Obviously, we've got a number of things that drive what we do on a day-to-day basis. There's the consensus spec, which is basically the complete executable specification for the consensus layer. There's an execution API, which is our interface to the execution layer client. So that's really important as well. In terms of APIs internally, we've got the Beacon API, which allows us to do things like produce blocks and submit blocks. Then there's the Key Manager API, which is also important, but it's more around validated key management. So being able to accept a new key, being able to remove a key that we're running. And then there's the Builder API, which is around building the execution layer section of the specification of the block. That's in preference to using the execution layer for some people. Some people fall back to the local execution layer as a default, but some people use the Builder API to do MEV. The other thing that does drive teams is obviously their actual team direction. So for Teku, as an example, we don't currently implement the light client. So there are sections of the consensus spec that we understand, but we don't necessarily implement. Another look at everything, basically consensus layer and execution layer both define open specifications. Proof of stake itself is basically like a really large, complicated, distributed game. Like any games, there's interactions that are pretty well defined, and there's a set of rules. And like any complicated game, there's definitely gray areas where, as much as we think the rules are going to be well defined, they're not actually perfectly defined. Because the consensus layer uses executable specs, it means that we can write tests on those specs, and then we can share those tests with all the implementations. So Teku, for example, can download all of those tests and run them, and just exclude the ones that we don't want to cover, like the light client. Looking at Teku, so our mission statement, if you like, is that we want to be the client of choice for institutional stakers. We are written in Java, so hopefully people can read a little bit of Java, but it's not going to be super code heavy today, so we should be good. We've got a lot of extensive metrics in that's exposed through Prometheus, so we've got a really good dashboard, which I probably won't show today, but we do have it and it's openly available to everyone to use. And we've got a big focus on testing. If anyone's seen the testing triangle before, so you'll have a large number of tests at the unit test level. And then as you go up the triangle, there's less at the integration level and there's less at the system level. But covering all levels is generally a good idea so that you get the coverage that you need. We're pretty focused on logging. So we basically use Log4j. We were impacted by the Log4j thing a couple of years ago, if anyone knows about that. I think most client teams were. And we run one code stream. So some client teams will use branch development where they do features in different branches and then bring them in towards the end. We don't do that. We use trunk development or master development. And we release all of our code frequently. So anything that we do needs to be either active or behind a feature flag. If we don't want code to be in the release, we need to make sure that we're disabling it. We've got a ton of documentation. The product is open source, and we do support on Discord through the consensus Discord, as well as we do have a presence in the ETHStaker Discord, and there's a Teku support channel there. And lastly, we are node operators. So we run Teku on mainnet, and we run Teku obviously on testnets as well. Some people call that eating your own dog food, if there's anyone that's heard that before. That was an overview of kind of consensus layer and Teku. Are there any questions so far?
There is only one question, whether Teku uses Gradle, which I believe it does.
We do use Gradle, yeah. Gradle is our build system, and we currently release to Artifactory.
And one more now. What is the reason that Teku doesn't implement the Light Client API? Why not?
Good
Why not
question.
focus on Light clients?
Yeah, for sure. Basically, it's a historical artifact of not having many resources. When we started Teku going towards phase 0 release, we were down to 2 developers for a while, so there was just no capacity. Now that we have 7, we have enough to keep up, but we would probably need at least one more resource to be looking at doing a whole new code stream. And we did get some protocol fellowship person to start doing it. So there is a start on it, but we just don't have the resources, basically. It's not really a focus of the people that our business statement are aiming for, so we haven't found it to be a huge issue, but it would be nice to be spec complete as well. So just competing drivers.
Yeah, get it. Thank you, Paul. Yeah, I think you can go ahead. Thanks.
Cool. I had a brief look over the material that was in the week 8 stuff, and Adrian's demonstration, Adrian's talk about all of the modules that were already in Teku was actually a lot more complete than what I realized. So I haven't gone into the details of how Teku's laid out. So hopefully people have had a look at that talk, but if they haven't, it's not a huge issue. We just won't be covering exactly that today because there's no point going over the same stuff. At a very high level, we've laid out our modules in a way where it's kind of like a hierarchy. So we've got infrastructure at the bottom level. We've got Ethereum that sits above that, and basically infrastructure can't pull in anything from Ethereum. It can pull in at the same level, but it can't pull in up the stack. And that goes the same for the beacon and validator modules, and it goes the same for Teku. So Teku can consume all the way down the stack, but infrastructure can't consume anywhere up the stack, and beacon can't consume up the stack. There are some tools that sit to the side, and we do have reference tests. But this is kind of our guidance for developers to say, make sure that we're not causing cyclic dependencies. One of the things that can happen, because IntelliJ is fairly tolerant, we can introduce a cyclic dependency and not really know. So there are build checks to make sure that we're consuming things in a nice order and not causing other people problems. Because sometimes when people import the project into Eclipse especially, it has caused problems in the past. Most of the developers use IntelliJ and it doesn't matter a lot, but Eclipse is very opinionated. I'm going to dive first into APIs a little bit, because that's one thing that has changed since Adrian gave his talks. They were fairly light on the APIs anyway, but we used to use an annotated set of objects to do our APIs, and now we've changed to a more declarative style. If we have a look at where APIs are and what they're used for, in terms of the operator, they may need to interact with the beacon node, and they may need to interact with the validator client for a couple of different reasons. We've got the beacon API, which allows accessing actual data from the beacon API, from the beacon node. You can get state data, you can get block data, you can produce and submit attestations and all of that sort of thing. And that will go straight onto, like, the beacon node will submit it to the network. The validator client itself is a small client that is just managing keys and making sure that duties are done. And it can use the beacon API to do that. But from an operator perspective, the key manager API allows an operator to add or remove a validator key at runtime. So that's kind of a nifty API. It does require a lot more security. I think in the key manager API, we recommend only using SSL, and we also recommend it being password protected, because these sorts of things are dealing with private keys, and it's super, super sensitive. So it would be bad if you lost your private keys. Hopefully we all understand that. I'm happy to go into it, but that's what the key manager API is around. From the beacon node perspective, the APIs it mainly consumes are the engine API to talk to the execution layer, and the builder API, I believe it's called, to interact with builders and relays to interact with MEV. It's not required to be using the builder API. You can simply have a beacon node connected to an execution layer, which is what I have at home. It does simplify the setup, and there are situations where the beacon node might need to turn the builder API off so that we can produce blocks, because our number one important thing is liveliness of the network. The other API, which I won't get into at all today, I won't really touch on anything except the beacon API. There's a signer API that allows external signers. So if you're using Dirk or Web3 Signer, they'll implement the signer API, and the validator client will go via them to sign rather than signing themselves. It allows things like sharing a signer and making sure that everything's centrally controlled, which is a better high availability solution than just having a local signer and having to do slashing protection by yourself. So this is probably obvious, but just to state it, APIs are the interface to the world, and for the world to access the beacon API. It's secure by default. So for us, that means we have an access list, and it's only accessible by localhost, and also it's accessible only on 127.0.0.1. We use a declarative interface, which is the interesting bit. We ended up having to write our own, which is never my first choice, but in this case, it made a lot of sense. It's called type definitions, and we'll have a look at some examples in a minute. And the type definitions allow us to define parts of the object to expose and parts to not expose, not explicitly parts to not expose, but basically we can say access these attributes of an object, which is quite useful if we've got an object that is slightly different to what we need to share on the network. And they're all based on SSZ. So SSZ is strongly typed, and it has all of the information about what we want to share. And we wanted to be able to leverage the data that's already there so that we don't have to redefine it all on our API layer, which is what we were doing when we were creating the old objects, which we'll also run through in a minute. A very simple type def example, we've got a class called post attestation. That's when the beacon node is actually trying to submit a signed attestation to the beacon node. Sorry, when the validator client is trying to submit a signed attestation. This is kind of the structure within the body of the object itself. But this is where we're declaring what we want to use. So we're saying that in a request body, we have I'll stop clicking. We have a deserializable type definition. So it's going to be coming in across the wire as JSON, and we're going to consume that JSON and turn it into a real object. And we're going to be using the attestation schema. So each SSZ object defines its schema, and we're going to be leveraging off the attestation schema, and we're going to be expecting it as JSON. In terms of responses, OK is a good response. That's 200 for anyone that loves HTTP codes. The other code that's likely is a bad request code, which is 400. And a bad request code has to be defined as a JSON type as well. So we tell it, we give it the type of, we give it a declaration of what it's going to look like as a valid object. If we have a look at, hopefully that changes. No, hasn't changed the view anyway. I was hoping it would stay on the view. All right. Excellent. So, I'm running out of room. So that's defined in the constructor. And then in the handle request, which is the predefined interface that's there, we basically get the request body. And when we call submit attestations internally, we get a future. So it's an asynchronous request. And we may get a list of data errors. And then basically, we respond asynchronously. We need to queue up a response to say, once this future resolves, then we're going to go through and render any errors and decide on an error response if there's an actual error. We have unit tests. I'm going to have to stop and start a lot. Sorry about that. I should have just clicked on the other link. I won't. Maybe I won't go into the unit tests. I should. Sorry, I didn't realize I was going to have to stop and start. All right. Our unit tests are in JUnit, which is a pretty common framework. And in the unit test, we're not using mock server or anything complicated. Basically, obviously, we want to make sure that we're able to submit that type of object. So we would submit an attestation type and we would expect to get back OK. And the response body should be null. In terms of when there's invalid attestations, we would expect to be able to get errors back and get a bad request response. And then we go into some other tests around the body. I'll have a look at your comment, Josh, in just 1 second. That'll be easier. Let's try that now. Share screen. Oh, entire screen.
Yeah.
Nice.
You see it now? Cool.
Yeah. Okay. That's
Great.
much better. Did I not click share? Entire screen. Oh, apparently I don't have permissions to share an entire screen. Sorry, guys. Are there any questions while I fix this permissions issue?
Yes, there is a one big question about whether you share any libraries with Besu, like whether there's some collaborative work there.
That's a good question, actually. We do share a couple of libraries. The main one is actually around Prometheus. So all of our metrics go through a basic library, which is saved us having to implement any of the metrics themselves. We do have rapid classes that allow us to do our own thing. Just gonna have to quit and
Okay, I will be back very soon.
Yeah, Paul is making it so he can share his entire screen. I think he didn't realize his browser was running this session. So we'll be back right in a moment here.
Meanwhile, feel free to ask him questions. Also, if you have any questions unanswered from previous consensus-related talks, feel free to post them. All right, hey.
Call me back. Apparently, quit and reopen Chrome means quit and reopen this. Oops. Now I should be able to share the entire screen. I was just saying, we do share basic libraries, which is mainly around the metrics. So other than that, I don't think so. I know Web3 Signer pulls in a lot of our REST API stuff. I don't think hopefully they don't anymore, because we're getting rid of most of what they use. That is something that I have to chase up on sometime very soon. Now I get the fun of logging into everything.
Yeah, that makes sense. Metrics can be basically the same thing, but the other parts are very different between EL and CL. And yeah, we'll let you know when there are more questions come in.
Yep, I'm just logging into. We have a lot of authentication requirements now, so closing the browser was actually really bad, but I'm getting there. It's always the way. We were all the way down. Okay, let's try again. No, not slides. Share screen. Oh, yay.
Awesome.
All right. Why is that coming like that? All right, I'm just gonna. That's better. Now it's actually changing for you. One of the things that we noticed was a gap when we were developing APIs, actually in the when we were using annotations, is that we could very easily change the definition of an API and not see that the definition had changed. That's actually really bad, especially on REST API, because the definition is really, really important to get right. So we ended up basically dumping the JSON schema so that tests can reference that JSON schema to be able to validate that that we haven't changed things, or at least show us when we have changed things. It's a pretty low-tech solution, but it's very effective. We end up getting these files where, in this case, we're looking at the post data stations. We're looking at the route ETH v1 beacon pool attestations. There's two routes on that. There's a get datagram and there's a post datagram. The get's defined here. We'll scroll down because we were looking at the post implementation. So in terms of the post, It has a couple of tags. It's part of the validator required API, which is actually really important to know. Any validator that's implementing the REST API has to implement this post function. It's a tag, it's a low-tech solution to say you need to implement this, but it's turned out to be quite effective. And then basically we're expecting a REST body that has to have the type attestation. And the valid responses that we get are 200, 400, and 500. 500 got magically added. We didn't really want to have to hack in 500 every single interface, so we made it part of the default set that we would just always add that in our declarations. This interface was really handy to have when we were switching over to type definitions, because we were able to then see what we were missing when we were changing the interface. Rewriting a whole library is a big undertaking, and if you don't have adequate testing beforehand, you're really not going to have very much fun. Oh man, that's ugly. That's most of this example. Did anyone have any questions on that? The reason that I thought that this might be interesting is because this is our own library, so it's not something that you can find online to find references of. It's something that you really need to either follow examples or ask one of the Teku devs.
Great, it's interesting. We don't have a question specifically about this example, but there was another related question. Do you use any dependency injection framework?
Dependency injection framework. None comes to mind. We do. No, none comes to mind. We might. I don't think so. We do have libraries that people use to fuzz and stuff, but that's not really what the question is.
Right.
I guess that's injecting fuzzed data, but yeah. I'm going to say no, but I could be wrong.
Okay, fair enough. Yeah, thank you, Paul. I think we can move along. Yeah.
Cool. The next example is also. I love my mouse wheel. Sorry. The next example I'm going to go into is also around using the type definitions. This one's slightly different because what we end up doing is we bring in an object, which is our own wrapper object called object and metadata. We were finding that often we need to return some sort of generic object, and in this case it's a bytes 32. In some cases it's an entire block. But with that data, we also need whether it's finalized and whether it's in post-merge world, there's a mode called execution optimistic. So we don't really have all of the data. We think that it's valid, but we don't really have the data from the EL. So we found that we needed that type of definition a lot, and we created this container for it. So we can pass in an object and metadata that contains bytes 32. And in this case, although we have that structure, we need a different structure to output. And that's why this is more interesting in a way than the last one. We're defining a field that is data. And to get that data field, it's actually of root type. So it's actually recursing into this definition, which has a field which is root, and it's bytes 32. So that's the actual data payload of this get block root function. It's also got the execution optimistic flag, which just comes straight off the object, and the finalize flag, which just comes straight off the object. For this one, the testing is actually very similar. So you should return header block information. We try and use mostly meaningful test names. Sometimes they get exceedingly long, but we do try and make them fairly descriptive. And it's a source of code reviewed comments all the time. The metadata ones, again, are very similar to the other tests. What we're doing here is validating that that type definition has everything that we need. So we know that we need to be able to return a 200 response, and we know that we need to be able to return a 400 response. If the object definition doesn't contain those, then we're in trouble, because it'll turn a 400 response into a 500 response, and a 500 is an internal error, which is still an error, but it's not a great response from a REST API. But basically, the unit tests are more interested in that metadata definition, and the integration tests are more interested in actually what happens when you get, in this case, the object definition itself, I guess. This one's fairly easy because it's mostly a block root. So it's throwing out to another object, which we won't look at. Get block root isn't heavily used. The other one, the post attestation, is heavily used. So the other one gets tested every time we run up a validator that's in remote mode. It'll be using that interface, and we'll know very quickly if it breaks. The other thing we do have when we're looking at APIs is, this is our own version of the documentation, but this is also on the Beacon APIs repository. There's a way to look at the object definitions. So this is the interface that we were looking at just then. It has a path parameter, which is the block ID. The funny thing, I think, with this one is that you can pass things like head, or you can pass the block root, which I think that's just because block ID is a standard definition, but it seems a little bit weird to be able to pass the block root and then get the block root back. But that's just one of those weird design outcomes that can happen sometimes. So that is a relatively simple couple of examples on type definitions. I'm going to move on from APIs in a second. Is there any other questions on APIs before we continue?
I don't see anything specific about APIs
Awesome.
at the moment. Yeah.
Cool. We'll get cracking into the next section. I gather you've looked a bit at EIPs and the EIP process. I'm not across the entire process, so this is all from the perspective of a developer who's starting on the prototyping section. So I may be misrepresenting things, but here's kind of my take on it. So we get to a point in time in the EIP process where we're not just a research project anymore, and we want to start looking at how we're going to implement something. So we start in this round of kind of prototyping, and it's no longer research. We often discuss these things on Discord, so ETH R&D Discord. For some things that are larger, there's dedicated channels. Sometimes they are on Telegram. It just depends where the conversation starts, and often there ends up being a bridge between the two. It's a fairly organic and muddy process, so it is hard to understand what happens because it's not always the same. When we're doing this, we're looking at things from more of an engineering mindset. So we're looking at more holistically the system that's there now and trying to fit something into that system with knowledge of the rest of it. So it's kind of this case of we're trying to make the EIP like actually fit into an executable spec and make sure that we understand how the EL and CL are going to interact. And sometimes there's definitely missed bits. After an EIP's been mostly accepted, and working out the details is a big part of how things go. This is all very vague and hand wavy, and we'll move into a concrete example where I can explain more what I'm talking about. EIP 7251 is around maximum effective balance being increased. And it is true that I'm looking at this because I'm currently implementing it, and I feel like I have a reasonable understanding. So basically, as part of this, we're looking at the initial penalty when a slashing event occurs. The slashing event gets expensive even for a single validator. We're looking at 1 ETH being the initial penalty that one of the current validators would incur if they were to be slashed. And just to be clear, because slashing is used a lot in a lot of different ways, anytime someone incurs a penalty on the network, we just call that a penalty. If someone has done something intentionally bad and we deem it bad enough that they should stop participating on the network, we call that a slashing, and only that a slashing. So the result of what I'm calling being slashed is literally being kicked off the network. The initial penalty for a small validator isn't too bad, but once we scale it up to max EB, the initial penalty with the rest of the rule set today would look like 64 ETH. It's linear scaling, so in some worlds you could argue that that's fair, but the reality is if I was to have 64 validators on a box and one of them gets an attestation slashing, the rest could be perfectly fine for a period of time, depending on which slot they're attesting to. So I could turn that node off and I would have only been slashed for one validator or a small number of validators. In the case of consolidating all of that into a single validator, I would have incurred 100% of the penalty when previously I would have only incurred a small percentage. So from that perspective, it's not super fair. So what they're looking to do is for the initial penalty, make sure that that initial penalty approaches nothing, which works for everyone. It's not penalizing institutionals, it's not penalizing solo stakers. When we had a look at this to put into the spec, the thought came to mind around whistleblower rewards. What happens when you get slashed is that someone gets a reward for reporting it. In reality, it's the block proposer. In theory, it could have been a third party that produces that's going over all of the data and trying to report on who's been bad. In this case, a 2048 ETH validator, which is the max, would have created a 4 ETH whistleblower reward, which is awesome, and a lot of people would be really happy. But the problem with that is we're actually minting ETH. The penalty no longer pays for that whistleblower reward, which, if we go back to game theory, is infinite resource generation, and it's something to be avoided. So ultimately, we don't want to mint ETH. The solution for this is the whistleblower reward needs to at least be covered by the initial penalty. That's an interesting case of when an EIP gets to the real world. I'm just going to read a question.
Yeah, we have one question here regarding the changes here.
Is it looking at phase 0 spec? That sounds like about phase 0 spec. I'll have to get back to you on that one, but I'm fairly sure. It changed in Bellatrix to be 1E, I'm fairly sure. If anyone's been looking at the consensus spec, the other thing we do is we create basically a difference between the previous version and the next version as a definition of the next version. So it can be confusing to follow, but I can chase up that question, Maris. I can't answer it right now, but I'm fairly sure in Bellatrix it changed to be 1E. Basically, the reward quotient changed.
Yeah, I copied the question for Paul, so it's a bit long, but we have this discussion in Discord, so maybe if you will join our little Discord server later, you can follow up there. Thank you.
Yeah, okay. Do you want to just shoot me a DM link for that, and I'll have a look at that later? Will. Awesome. Otherwise, I'll forget for sure. Anyway, when we pointed out that the initial penalty would go to 64, no one else in that group argued, so it's probably that I was right, but I can confirm that. So basically all of the features, all of the EIPs, when they go into the consensus spec, go into this _features folder. And in this case, we've changed validator now as well. We had only changed beacon chain and fork, but it looks like we've now changed another file. These are a difference on the specifications. So when these say, we're going to be jumping into one specifically, I think. We're going to be going to the beacon state. All right, so let's have a look at beacon state. So these redefine the object. And then at a point we start getting new in. So we know that 7251 is what we're looking at. We've actually added a whole ton of new fields into the beacon state for 7251. So that's all of these. Some of them are lists, which are going to prove interesting. Someone the other day noticed that this is kind of the first time that we're going to be having to splice lists. So that's going to be a pain point that we haven't worked through yet. But in real terms, generally when we're adding things to the state, we're adding 1 or 2 fields, not 8. So yeah, it's going to get interesting. What I was going to show is, I might actually jump over to my idea. It becomes a bit interesting when we add things to our code base because of the history of how things have kind of evolved. So we do have changes in our actual versioned area, but we have this whole set of changes in our API area, API schema. These are the old annotated objects that we used to use. No, that's not what I clicked on. Yes, it is. No, that's JSON. Pending balance deposit. Okay, that looks better. So with our annotated objects, we have to, they're called POJOs, they're plain old Java objects, but basically we have to put annotations on every field that we add, and we have to put annotations into the constructor. We also need to create a constructor that allows us to take the real object, the versioned object, and produce this object so that we can convert both ways. So we need to be able to go to the schema objects and from the schema objects, depending on the scenario. This whole folder basically is tech debt. Because we don't use it anymore except for in some specific scenarios, but it still needs to be defined because it's changing the state, and the old API still references this. We use these for some of the validator API, for some of the validator clients interactions with the beacon node. But it doesn't require state, but we haven't removed that code path completely, so we still are maintaining those objects, which is a bit unfortunate. Having said that, it's a small change compared to the rest of the stuff, which all has to exist anyway. If we have a look just at the JSON object, there's a few new fields will be in there. They're also defined down through here. So that's kind of what it looks like in JSON land, and that's where these tests are fairly handy, is because changing the object has then changed the type definition that the object uses, and that flows through the object, all of the integration testing. So we can see exactly what's changed without looking at the code. And same thing, if one of these had changed from uint64 to something else, that would also be reflected here, and we'd be able to see that very easily. It's a whole bit of we have builders, and at the moment, this is only on my own branch, so I've kind of hacked in some constants, which I won't be doing by the time it reaches real code, but it was an easy way to get this off the ground. I'm assuming everyone's seen the builder pattern before, so I won't jump much into the builder pattern. The main thing I was going to say is there's a whole lot of stuff that changes just for those 8 fields. So it ends up in a big overhead for the team to wear. And that integration test was the annoying test that shows what we've missed, basically. This is one of the few times that we've used branch development. Normally, what we'll do is we'll just put things behind feature toggles. At the moment, we've got a case where we've got some features have been accepted into Electra and some are still being worked out, and 7251 is one of those that's being worked out. So it hasn't been fully accepted and it hasn't been changed to yes, it's definitely in Electra. So I'm keeping it on a branch so that I don't infect the other things, because once I add those objects into the state, then any other client that we talk to would need to be also dealing with the same state. Otherwise, it's going to get a different route and we won't be able to talk to each other. Another example from 7251, a really seemingly simple one, is eligible for activation queue. So this is a function that is having a look at a validator object and determining whether it is able to go into the activation queue to become an active validator. In Python, everything is snake case. In Java, it's really confusing to have mixed case where some things are snake case and some things are camel case, and all the main Java coding standards are camel case. So we've gone with camel case, and if we translate that, we get is eligible for activation queue, much more like that. One of these should be found when we do a search through the code. So we'll have a look at the code in a second. it was in abstract epoch processor, which is good. And then we can have a look at how we're going to define is eligible for activation queue for Electra, which has to change that function. So if I jump back into IE, it's a lot smaller change. The abstract epoch processor. The interesting thing is that it was inlined, which is okay. And we had a comment which was mentioning it is eligible for activation queue. If we have a look back at the spec, it's basically doing the same thing. It's just a little bit different. But it sounds like we're just trying to make sure that we don't have to read the whole validator object so that we make this determination. So without changing that logic, I've just split it out into a function. And basically then I just can override that function when we're looking in. I've gone to the wrong file. Abstract epoch processor. And so is eligible for activation queue is now dependent on min activation balance, which is a new field that's coming into play in 7251. Along with that, there was a bunch of other functions that needed to be defined. Has compounding withdrawal credential, is compounding withdrawal credential. I don't know that it makes it that much easier to pass through just the withdrawal credentials. I'm assuming that was done for tests. It's an overhead that I don't care greatly for, but it's not either like a big problem. So I've just done it the way the spec does it initially. And then there's a get max effect, validator max effective balance, which does make sense because we have to check the withdrawal credential prefix. If anyone's had a look at the dirty details of the validator, we've got a prefix which is 0x00. When withdrawals were active in Capella, actually well before that, there became this ETH1 withdrawal, which is basically 0x01, and then a whole bunch of zeros, and then an ETH address. We're going to be leveraging on that and making a 0x02 for compounding. I wouldn't suggest anyone watching this changes their uses 0x02 at the moment. There's nothing stopping you, but it's probably not good until we determine all the details to change to. So anyway, the 0x01 is the most common that you'll see on mainnet now, which means that withdrawals are basically worked through in a loop. And over a period of a few days, everyone gets their partial withdrawals processed. The new compounding one will change that a little bit, and the details aren't finalized yet as to exactly that's going to look like. We have a bunch of presets that get changed to add some new fields. And we have different network configs. So mainnet obviously is the one that most people are aware of. Minimal is a handy network config for running during development because it doesn't need quite so many things, but it does start from phase 0. And Swift is one that we really only use for testing. It's very, very short epoch time, so it allows us to do things like run acceptance tests in a very fast way where we get to finalization without having to wait for several minutes. But they all need to be updated for Electra. So that's just going through that. And then we have these objects in testing that basically just define some defaults. They're fairly arbitrary, so I haven't defined perfectly each value, but they give us a representative for writing tests against. So that change is a lot smaller, but it is also only targeting one function, and we've ended up implementing 3 or 4 because we were looking at that min activation balance. So that's kind of what you go through when you're prototyping out the functions. Obviously, there's tests involved, and there's a framework that we will have to add to. So when reference tests are added to the spec, we'll be able to then call some of these individual functions to validate that they're doing what we think they're doing. But for now, we don't have those, so we're just implementing the code itself. That was a little bit random. Is there any questions on that?
Not questions on this part. Maybe something for later. But some bit unrelated question. What is the database engine that Teku uses?
Currently, we got 2. When we started at Genesis, we were using RocksDB only. We had problems with being able to upgrade RocksDB sometimes, and they do have a lot of kind of false starts with some of their releases where all of a sudden things regress. So we did switch to LevelDB. We have found that LevelDB is not really very actively maintained now. So we are considering switching back to RocksDB. Basic obviously uses RocksDB, and there's a lot of expertise in that area in the greater team. And for anyone that is curious, Consensus does run a large team of people maintaining Hyperledger Besu as well. So that's why Besu is sometimes a consideration for Teku in how we're doing our development, because we do have a lot of expertise inside our own group for a lot of Besu stuff as well.
Right, thank you. That's interesting. Yeah, because also Get moved from LevelDB to Pebble, and it's interesting to hear that you go back to LevelDB. Oh, thank you. And another question: what do you find most challenging in the Teku development, or which part of the code base are the hardest to maintain, to work on, implement the features?
Storage is the hardest for sure. The database storage doesn't change very often. So what you get with that is basically the tests aren't heavily understood. Sometimes they're written by usually people that have left the team, because it's not super common that we need to change them. So once we do eventually dive into changing anything in the storage layer, it tends to be a little bit of an overhead. There's a gentleman in Europe that's been here a little bit less than me, but for a fair while. So usually it falls back to one of us to be having an eye over any storage change. And there are sections of the code. So when we look at the 2 ways we can run as a beacon node that's combined to be able to run validated keys in the same process. Or we can run with a split out validator client. So in those 2 modes, there's a parent class for each one. There's a beacon chain controller, and there's a validator client service, I believe it is, off the top of my head. Those 2 are like the parent classes where everything is built from. But if you need to add something like the key manager API, which could be run in that combined process, or it could be run in the validator client service, you really need to be understanding where your flags are going to become active. We use Pico CLI for our command line flag argument processing stuff.
Right, interesting. And so you have two distinct classes for the beacon node and the validator. We had a question about the validator code, but I think we can get into that later, and you can just keep going and finish the presentation because we are over an hour now. So
Yep, sure.
we'll just keep it going.
I have a couple of other slides, but they were really in case I ran out of time. But this kind of wraps up the EIP kind of thing that we're looking at. So in terms of how our team is operating, we'll allocate an owner to an individual EIP. So some people, for example, would have got EIP 7002, which is an Electra confirmed EIP, and it's quite small. And some people like me got the MaxEB EIP, which is quite a lot larger. The person who owns it is going to obviously break that project down into tickets, or I've said chunks here, but basically issues on GitHub. Ideally, we're going to present an overview to the team so that people understand what's involved in the changes and have a bit of an overview of everything. And then that person's going to be kind of on the hook for making sure that things are delivered. So just making sure that that test nets are all, we're joining them, we're not having any issues on them. If the spec changes, keeping up with those developments. And depending on the feature itself, 7002 was quite small and it was easily implemented by one person, but MaxEB is looking like it's going to be quite a large feature. Blobs, for example, was a very large feature, and we had half of our team on blobs. So you might not be implementing the entire feature depending on that size. Withdrawals is another good example, which was in Capella. I owned that feature and I was responsible for making sure that everything was running okay, but there was another person on the team that helped me get through some things just so that we could deliver and be on time for the testnet. That's about it from team side of it. We don't have a product owner at the moment per se. We're mostly just managing it within the development team. And we do have, because we have a Europe presence, they tend to go to the all core devs calls. And I tend to be asleep in my bed at that time because it's 2 a.m. our time. That's about all I was going to look at from the EIP kind of perspective. And I'm hoping people find that useful. If there's no further questions, I do have a quick performance thing that we could run through, or we could wrap it up there. I'm easy either way.
Thank you so much, Paul. And yeah, it's also very interesting to see how it works within the team. It's an interesting insight. And let's see if there are any questions about the EAP process. So far, we don't have any. But it's very interesting. Thank you so much, because we've been using it kind of as an example of how the changes implementation things is done in the Ethereum. That there is some EIP idea which goes through some research process, and then it's implemented, and it's great to dive into that to zoom in on how it's actually happening. So it's really helpful. Yeah, and let's see if we have any related questions. Otherwise, I'm very glad to continue to give you more space. And we have like maybe 20 minutes left, if that's okay with you, of course.
Yep.
So we can use the time. Somebody's typing, so I just want to see if there is a relevant question and if it.
Yeah, no problem.
Okay. Unrelated question, but still, whether you are working on implementation or any research related to EPBS in Teku, maybe similar to
EPBS, not currently. I'm trying to follow the conversation on EPBS. It's very long.
Yeah.
And if anyone is interested, there's an ETH R&D channel for EPBS. It'll be interesting to see how it pans out. At the moment, I don't think it's looking like it's going to be in Electra. But there's a lot of considerations to be had.
Yeah, interesting. Thank you. Any more questions? Something related to the implementing VIPs process. Okay, I think we can go on. If you have more content,
Yeah.
just feel free to continue. Yeah, thank you.
Okay. I was going to mention just a quick performance example. I'm sure this is potentially language specific, so sorry for anyone that doesn't look at Java, but Java has synchronized functions, and synchronized functions are basically run as a single process, so only one can run at a time. When I was looking at performance on Holsky, one of the things that I did was I tried to scale up what the machine was doing on Holsky until a point where it started breaking. It can be a useful indicator of performance when things are starting to go negative. So I started with 10,000 keys and that ran fine. I upped it to 15,000 to 20,000. 20,000 things started going a little bit south, but I wasn't happy with that, and I upped it to a single node to be running 30,000 keys, which is very not ideal, but it did show an interesting pattern where when we're doing our local slashing protection, we need to run these functions that maintain the slashing protection data to ensure that we can't be slashed. Those functions are actually synchronized. So we started hitting a bottleneck, not as much on baseline block, more so on the attestations, because your validators on average, you can look at 1/32 of your validators that you're running attesting in every slot. So if I'm running 30,000 validators, that's quite a lot of validators that end up attesting each slot, and each one of them have to write an update to a file, which is fine. It's a very small amount of data. But if it's a function where it's basically locked, that across those 30,000 validators, I can only check one validator at a time, it becomes quite a resource constraint. So there was a little tiny feature that was a little bit scary to do to basically remove that synchronized. If you look at it it's not a new solution, basically. If you look at databases, relational databases, they initially started with a table level locking scheme, and they eventually determined that row level locking was a lot smarter. Basically, this is similar to that in that I'm locking one validator. So multiple validators can be accessed at once for their slashing protection, but one validator can only be updated in a single sequence. So you end up needing a bunch of locking data around that validator. So I actually have a bunch of records, and the local slashing protection record ends up having its own lock. But the net result of that was about a 15% increase in our effectiveness on attestations. So it's funny how sometimes one little design decision, which is okay at low levels is not okay when things scale up. So I thought that was just maybe a fairly simple performance related one that we look at sometimes. Another example that I don't have on the slide is uint64s are a full-blown object in Teku. So when I was looking at reducing memory size, I was trying things for weeks and weeks, and then I had a look in our memory analyzer, and it turned out that we had millions and millions of objects that all said 32 ETH, which was this uint64. So I could save several hundred meg just by making a single static variable to have 32 ETH value in, which still blows my mind when I think about it today. So there's some interesting performance stuff that happens in the background when you're doing development. The only other slide I had, probably a timely question, how do I become a core dev? The number one thing that always answers this question for me is get involved. Don't assume that you're not in a place where you're able to help out, because a lot of people can help out more than they realize. So my advice would be to pick a project. A good example person is POTUS, who basically got into Prism because he was implementing a feature that he wanted that no one else wanted to implement. So he taught himself how to do it and is now on a core dev team. But pick a project, try to use it, and familiarize yourself with it. If you did pick Teku, obviously we've got the consensus Discord. In that, there's 2 channels. We've even created a Teku contributors channel. So shameless plug from our side, if you do want to get involved, that's a channel that you could be talking on if you need help finding things, or if you need help understanding the code. We do have developers looking in there. Even ETH R&D is a really good place. EPBS was mentioned before, and there is a channel dedicated to EPBS. So if you are interested in that, I would be joining that channel and trying to get your head around how things work. And also, a lot of teams have hiring pages. Consensus hiring pages always there, and I think we are hiring for core devs at the moment. And this is just from me, because sometimes I'm my worst enemy. Don't let yourself doubt be anything that holds you back. That is everything I had.
Awesome. Thanks so much, Paul. Yeah, also for those of you still listening, joining programs like this study group as well as the Protocol Fellowship are great ways to get a little bit more structure and guidance through your journey into core development, if that's a path that you'd like to take.
That's a good point. Protocol Fellowship is really, really good. We have had a lot of good experiences with people from there as well. So it's definitely worth mentioning for sure.
Yeah, actually, I wanted to ask about that. Maybe if you can give people some tips on their first-time contributions. You had a good experience with a fellow from the EPF before, so maybe some things that you liked about that interactions, or how whether you have some tips for people.
I think I didn't actually have to do very much to specify the project that was worked on previously from that, because it was already predefined, I think, by the gentleman that did the change. But they were very interested in Light Client, basically, and wanted to implement Light Client for Teku. I suggested that doing it properly rather than doing the whole thing as a shallow dive would be a better option. So we ended up developing a actually, he's probably one of the recent people to go into the storage layer because he had to change that a fair bit and was able to produce some of the endpoints for like client. But because we were doing it fully tested and product ready, we didn't get all the way across it. So one day we will revisit it, but it was a good outcome for everyone, I think. And I think he got a lot out of it.
Yeah, awesome. And maybe do you have any? You mentioned good first issues. Maybe some other things where people can contribute to, or any like active research development areas where you you know Teku or the other parts might need help.
In terms of EIPs, they're obviously documented as they go through, and these things are free for anyone to join. So if people believe that they can contribute to an EIP, they should definitely get involved, reach out to the people that are championing it, and try to become part of the process. It's a lot of information is flowing all of the time, so the biggest challenge is finding where the information that you need lives. And ETH-R&D is an excellent resource for that. There's a consensus dev channel and there's an all core devs channel, fairly accepting of questions that are considered. I wouldn't go spamming them, but I definitely wouldn't feel afraid to ask a question. They're a fairly open bunch overall. There's the EIP channels. Obviously, keeping up with all core devs is like the calls. You can watch them back on YouTube. Some people's contribution is largely summarizing those calls. So I know Ben Edgington for a while was joining them and producing just like a bullet point summary of those calls, which I used to really appreciate because I could read that rather than watch the hour and a half back because I never see it. So people contribute in different ways. Obviously, there's the other side of it where people's contributions are more about airdrop farming, which isn't great, but yeah,
that's
interesting world.
Did you get a lot of spam from PRs or stuff like that from wannabe
Beacon APIs is the weird one. The Beacon APIs channel seems to get a lot more spam than I would expect, and I'm one of the main admins on that, so I probably see it more than sometimes. But like things like people commenting on closed PRs and stuff, I don't know what that gets you, but it must get you something because people do it a lot.
Yeah, right.
And it's time consuming for the dev teams who already have very little time, so I wouldn't suggest doing it.
Right. Yeah. I noticed it in some what you said, like old PRs issues and just random comments, and then like it's also kind of annoying on GitHub to block them because you need to file a whole report and it's just too long process. Yeah. Thank you, Paul. We had a bit more technical question. And I'm not that familiar with Java, but I think this is like a new feature in Java 21 using virtual threads. Maybe whether Teku uses them or whether you leverage the latest features.
At the moment, we're on to Java 17, so we're not using any of the new features in Java 21. I actually really wanted to use records, which I believe is Java 17, but the problem is the reality of how we do things versus how records want them done wasn't very conducive to using them either. So sometimes we do use new features, but it just depends on the way we're using things. Like the new switch syntax in Java 17, we have started using a fair bit, but other features like records we haven't really touched. Hopefully soon we'll start moving to Java 21, but we need to also be realistic about making people move just for moving's sake. So Our Docker image changes first usually because that's easy lift.
Right. Yeah, it can break the environment for many people. I understand it's a big step. Yeah. Yeah. Thank you, Paul.
Yeah, it gets listed as a breaking change.
Right. Folks, any other questions? Feel free to ask. We have maybe a few more, one last question or so. I'm not sure, Josh, do you have anything you would like to? I think we're out of the question pool already.
Yeah, I don't think so. Just big thanks to you, Paul, for taking us through Teku and giving us a good overview of that code base and how it works.
Very welcome.
Yeah, thank you very much. Yeah, I appreciate it. It was really great to see especially such a, I would say, kind of hot and interesting EAP as MaxEB. That's very heavily discussed. People have opinions, want to include it, so that was really great to actually see it in action. Yeah, thank you so much, Paul, and again, huge thanks for taking up picking up for us, and if you will have some rest today, have a good day.
No worries. Thank you very much for your time.
Awesome. Yeah, thanks a lot, Paul, and
All right, thanks,
we'll
Paul.
see you around.
All right.
Yeah,
Have a good day, everyone.
and to the rest of the study group, we will see you all in a couple of days on Wednesday for a chat with Barnaby Monod on MEV and censorship.
Awesome.
All right,
Thank you so much
thanks.
for following, everyone. Yeah. Thanks, Paul. Bye bye.